Okay, hey guys, so sorry I'm just going to restart this video because I was interrupted. So I'm just going to do Unit 4 again. So, Chapter 14, Randomness and Probability. So the law of large numbers and non-existent of law of averages is just basically saying probability is in the long run. And sample space is the collection of all possible outcomes and they add to 1. Probability of A or B when events A and B are disjoint. So disjoint is when there are no outcomes in common, and it's also called mutually exclusive. So when it's disjoint, you can just do probability A plus probability of B. And then probability of A and B is probability of A times probability of B. The events have to be independent though, if you do that. And independent is when the probability of one thing happening does not affect the probability of another thing happening. And disjoint events are never independent. And this is because, as you can see, disjoint over here, they're separate, but the definition of independence is that the events have to be happening at the same time. They just have no effect on each other. Now on to chapter 15, probability. So probability of A or B is probability of A plus probability of B minus probability of A and B. So for this equation, the events don't have to be disjoint because the minus probability of A and B is getting rid of the overlap. And then probability A and B, this one, the events do not have to be independent. And it's probability of A times probability of B given A. So B given A, this is conditional probability, is probability of A and B over probability of A. Independent, if the probability of B given A equals probability of B, or probability of A and B equals probability of A times B. So if one of those work, that means that the event A and event B are independent. When you see at least, often, not always, if it might be easier to find the complement, so doing 1 minus the probability. And then tree diagrams are also in this unit. Okay, now on to chapter 16, random variables. So, the center of the normal model is the mean, which is also the expected. And to find that, you can look at this table here. So this is an example of cost of repair. And so to find the expected, you do the sum of the x times the probability. So to find how I found expected is by doing $60 times 0.75 plus 200 times 0.25. So that's the expected cost of repair, $95. And now variance is standard deviation squared. And standard deviation is the square root of the sum of the x minus the mean squared times the probability. So for here, the mean is $95. So you do 60 minus 95 squared times 0.75 plus 200 minus 95 squared times 0.25. All right, and the probability of the column adds to 1. Now, in random variables, so you always want to do the independence assumption first because these rules won't work if the two variables are not independent. So mean behaves as you expect. If you add a constant, you'll just add the constant. You multiply, etc. And variance does a little different. So if you're adding a constant, that doesn't change variance. So variance of x plus c equals variance of x. You'll get the same number because shifting doesn't change spread. Variation of c times x, you'll do c squared times variation of x. And variation x plus or minus y will always be addition because you can only be the same amount or more variation. You can't have less variation when you're adding these two. So you're always adding, even if it's variation x minus y. And now to reinforce that, let's just do some quick examples. So if you look at that, so for example, if you're just shifting, so if you do x minus 20, so the mean, again, all you do is 80 minus 20, which is 60. And then the standard deviation is still 12 because standard deviation does not change. If you're doing 0.1/2 times y, so this is scaling now. So we're doing 1/2 y would be 6 for the mean. And now standard deviation, you want to do 1/2 squared times 3 squared. So that's 9/4. So you always find variance first and then standard deviation. So you're going to do 9/4, square root of that to find standard deviation, and that's 3/2. So that's that. And then x minus y. So x minus y, it'd be 80 minus 12, 68. For standard deviation, you do the square root of 144 plus 9. Remember, you're always adding, even if it's subtraction. So square root 144 plus 9 gives you square root of 153 as your standard deviation. Okay, now let's move on to chapter 17, Bernoulli trials, probability models, geometric, and binomial. So, Bernoulli trials, there are only two outcomes, success or failure. The probability of success, which we often write as P, is constant. So, for example, 15% chance of the racket breaking every time. It's constant. It's not going to be like 10% another time. And then trials are independent of each other. And if you can't prove that, you can say the 10% condition. So the trials are independent or the 10% condition. They both work. Again, Bernoulli trials, two outcomes, probability of success is constant, and trials are independent or 10% condition. P equals probability of success. Q equals probability of failure, which is 1 minus P because there are only two outcomes. So it's 1 minus P. Now, geometric versus binomial. So X, this big X is the random variable. And so you do X equals the number of trials until the first trial. So keyword is first. Number of trials until the first trial. So you'll have 5 trials until you get 1 success, for example. And to find expected, you do the mean equals 1 divided by P. To find standard deviation, you do square root Q over P squared. But you don't have to remember this because this is on your formula sheet. And I actually will be making a video later about all the formulas on the formula sheet because then you don't have to memorize as much of the formulas. Okay, and then binomial, the random variable equals number of successes in n trials, and n equals the number of trials. So, for example, you have 12 trials, or no, let's do this example. You have 5 trials, and the probability of the success is 0.4. So, and say you want the number of successes, you want to see the probability of there being 3 successes in 5 trials. So what you do is 5 choose 3 times 0.4 cubed times 0.6 squared. So what this is n choose x times probability of success to the x times probability of failure to the n minus x. And binomial, to find the mean, you get n times p, and to find standard deviation, you do square root npq. Okay, and then last thing, normal model conditions. So you use the normal model to find these, and it's either independent, it has to be independent to use the normal model condition, and the success failure, which is n times p is greater than or equal to 10, or n times q is greater than or equal to 10. And if that passes, that means the sample size is large enough and you can do the normal model. You can make a normal model. Thank you for watching. I will post Unit 5 as soon as possible. Again, the times on my schedule are not accurate. But hope to see you soon. Thank you for watching.